Hey everyone, welcome back to AI Tech Revolution. Today we're diving into some major revelations from NVIDIA CEO Jensen Huang that will reshape how we think about AI development and infrastructure demands going forward. In a recent CNBC interview following NVIDIA's quarterly earnings report, Huang dropped a bombshell. Modern AI reasoning systems require 100 times more computational power than previous generations. This isn't just incremental growth. It's a fundamental shift that will impact everything from chip demand to data center construction to energy consumption. Let's break down what this means for the AI landscape, the tech giants, and potentially your business decisions around AI implementation. First, some context. NVIDIA just reported their fiscal fourth quarter earnings, and the numbers are staggering. Overall revenue jumped 78% year over year to $39.33 billion. Data center revenue, which includes their AI GPUs, soared 93% to $35.6 billion. AI chips now account for more than 90% of NVIDIA's total revenue. These aren't just impressive numbers, they represent a fundamental shift in computing. NVIDIA has transformed from a gaming graphics company to the backbone of the AI revolution in just a few years. According to Huang, there are three critical phases in how modern AI systems work. Phase 1, pre-training. This is like AI's high school education, where models learn basic math, language, and general knowledge. Huang explains it as building a foundation of human knowledge, similar to our basic education. This phase requires significant but established levels of computation that the industry had already adapted to. Phase 2, post-training. This is where we're seeing massive innovation right now. Post-training involves several approaches. Reinforcement learning with human feedback, or RLHF, is like teachers giving the AI guidance. Reinforcement learning with AI feedback involves AI teaching other AIs to improve. Reinforcement learning with verifiable reward. Feedback is all about testing and practice with measurable results. Huang revealed that this post-training process can require 100 times more computational resources than the pre-training phase we previously thought was the most demanding part. Phase 3. Inference, also known as the reasoning phase. Instead of simply generating an answer immediately when prompted, modern AI systems reason about the question, break problems down step by step, reflect on potential approaches, generate multiple answer versions, evaluate and select the best response, and then present it to the user. This reasoning process at inference time now requires 100 times more computation than what was needed when ChatGPT first launched. Huang specifically called out 3 AI models as examples of this new reasoning approach: DeepSeek R1, OpenAI's GPT-4, and xAI's Grok 3. These models represent a fundamental shift from earlier generations. Rather than simply pattern matching and text prediction, they're actually thinking before responding. It's important to note that this contradicts some initial reports about DeepSeek, which suggested the company had found ways to get better performance with less compute. Huang directly addressed this, saying DeepSeek actually popularized reasoning models that will ultimately drive higher demand for chips. In his words, DeepSeek was fantastic because it open-sourced a reasoning model that's absolutely world-class. But that reasoning capability comes with massive computational requirements. This 100 times computation increase isn't just theoretical, it's driving unprecedented investment in AI infrastructure. NVIDIA's CEO noted that this year's capital investment for data centers is, well, so much greater than last year's, which was already historically large. Cloud providers like AWS are seeing demand they can't fully meet. Huang quoted Amazon CEO Andy Jassy saying, if he had more AI resources to sell through AWS, he could sell more. New AI startups focused on reasoning and AGI capabilities are emerging rapidly, each requiring substantial computing resources. These aren't gradual shifts. They represent a step change in computational demands that's reshaping the entire tech landscape. Huang mentioned NVIDIA's next-generation AI chip architecture, Blackwell, several times during the interview. He indicated there's a fairly good pipeline of demand for Blackwell despite its higher price point. The timing couldn't be better for NVIDIA. Just as AI demands this massive computational leap, they're releasing chips specifically designed to meet these new requirements. The interview also touched on how U.S. export controls are affecting the global AI race. Huang revealed that NVIDIA's revenue percentage from China has fallen by about half due to these restrictions. Chinese companies like Huawei are increasing competitive pressure in their domestic market. NVIDIA's GB200 chip, sold in the US, can generate AI content 60 times faster than the versions NVIDIA is permitted to sell to China under export controls. This creates a significant technological gap between what's available in different markets, which could have long-term geopolitical implications. This 100 times computation requirement has profound implications. For cloud providers, it means massive capital expenditure requirements to meet demand. There could be a potential shortage of AI resources for customers and prioritization challenges for allocating limited resources. For AI startups, there are higher infrastructure costs to develop and deploy advanced models. Increased capital requirements will be necessary for companies building proprietary models. This situation gives an advantage to companies with strong cloud partnerships or funding. For enterprises implementing AI, there will be higher costs for running reasoning-based AI models. ROI calculations for AI projects will become more complex, and there may be a potential stratification between companies that can afford advanced AI and those that cannot. For hardware manufacturers, there will be an unprecedented demand for high-performance chips. Supply chain pressures to deliver components will increase, and energy efficiency will become even more critical. One critical aspect not directly addressed in the interview, but impossible to ignore: energy consumption. If AI systems truly require 100 times more computation, what does this mean for power requirements? Data centers already consume massive amounts of electricity. A 100 times increase in computation doesn't necessarily mean 100 times more energy, but it does suggest significantly higher power demands, which raises important questions about sustainability of AI development, geographic constraints based on power availability, and potential innovation in energy-efficient computing. We're clearly at the beginning of what Huang calls the reasoning AI era. This isn't just another incremental advance, it's a fundamental shift in how AI works and what it can do. The companies that understand and adapt to these new computational demands will likely emerge as the leaders in this next phase. For investors, this suggests continued strong demand for AI infrastructure companies, cloud providers with strong AI offerings, and chip manufacturers. For businesses implementing AI, it means carefully evaluating which use cases truly benefit from these more advanced reasoning capabilities versus which can be served by less computationally intensive approaches. The 100 times computation increase Huang described isn't just a technical detail, it's a paradigm shift that will reshape the entire AI landscape. We're moving from systems that simply predict text to systems that actually think and reason. This is exactly why we focus on practical, results-oriented approaches to AI on this channel. Understanding these fundamental shifts helps you make better decisions about where to invest your time, resources, and attention. If you're thinking about implementing AI in your business or investing in AI companies, this computational reality is something you simply can't ignore. That's it for today's analysis. If you found this breakdown valuable, please hit that like button and subscribe for more insights into how AI technology is evolving and what it means for your business. For those interested in going deeper, I've just released a new AI implementation guide that helps you evaluate which AI approaches make sense for your specific business needs. The link is in the description below. And as always, let me know in the comments, how do you think this 100 times computation increase will affect your industry? I read every comment and love discussing these developments with you all. Thanks for watching, and I'll see you in the next video. #A Tech Revolution #NVIDIA I compute #Future of AI.